Hello everyone, I am Anjali Daima from SAS Institute of Management Studies. My topic name is assignment problem. So we will see how to solve the assignment problem of operation research. What is assignment problem? So assignment problem refers to the special class of linear programming problems that involves determining the most efficient assignment of people to projects, salespeople to territories, contracts to bidders and so on. Each assignment problem has a matrix associated with it. The number of table indicates cost associated with the assignment. The most efficient linear programming algorithm to find optimum solution to an assignment problem is an Hungarian method. So let us see. Assignment problem using Hungarian method. Hungarian method is a combinational optimization algorithm that solves the assignment problem in polynomial time and which anticipated later primer dual methods. It was developed and published in 1955 by Harold Kuhn, who gave the name Hungarian method because the algorithm was largely based on the earlier works of two Hungarian mathematicians, Denis Koenig and Zeno Evegre. Requirement of dummy rows and column. Why the assignment problems require the dummy rows and columns? The matrix should be equal to, there should be equal number of rows and column in the matrix. Then only we can do the assignment problem. If the number of tasks that needs to be done exceeds the number of resource available, dummy row or dummy column just need to be added, as the case may be not done properly. This creates a table of equal dimensions. Example of assignment problem. A company has 5 jobs to be done by 5 workers. Each worker are assigned to one and only one job. Number of hours each worker takes to complete a job is given with. So here W1, W2, W3 denotes the worker and J1, J2, J3 denotes the job for that particular worker. So first step to solve the assignment problem is row minimization. Row minimization is done by seeing the particular row which the value of the row which will be the lowest value will be deducted from each value. So in the first row we can see 24 was the minimum value, so it is subtracted from the other values. So we have to do so on with the other rows too. In W1, W2, W3, W4 and W5 we have to do the same process. Second step is column minimization. Column minimization is done vertically, so we can see J1 column. In J1 column, 0 was the minimum value, so it is subtracted from the other values. So on J2, J3, J4, J5, we have to do the same process. Step 3. Starting from the first row, if there is exact 1 0, make an assignment and cancel all the 0 is that column and then draw a vertical line. Similarly, starting from first column, if there is exact 1 0, make an assignment and cancel all the zeros in that row and then draw a horizontal line. Continue this step till all the zeros are assignment cancelled. So as you can see, the cancellation of line for 0, second, and zeros are cutted together. So as you can see, we had made only 4 lines and no more zeros are there. So the number of lines are not equal to the number of matrix. So third step, if optimal assignment is not formed, to go to the step 4, that is there should be 5 straight lines. So we have to make again the lines and cancellation. So here you can see how the lines are made. Step 4. Ensure all the zeros are covered with the minimum one line. Find the minimum element not covered by any line. In this sum, 5 is the minimum element not covered by any line. So we have to cancel. So 5 was the element, so we have to subtract it and also add it. Elements not covered by line, also add the same element to the element which are at the intersection point. So at the intersection point we have to add it, and otherwise we have to less it. So you can see in the given table. And now we have to again make the lines. Cover all the zeros with the straight lines again. Since 5 lines are needed, an optional assignment can be made. So same process we have to do it again. So in the 7th step, assign J1 W3, and we have to put here the actual question value, so we will get the answer properly. So minimum total time needed is 126 hours. Hence the optimal solution is unique. So it is a unique type of solution. Minimization, maximization problem. Assignment problem can also be solved cases of maximization model. For instance, traveling salesman problem, milk van routines, and so on. Problem can be solved by first subtracting the biggest element in the problem from all the other elements, converting cost table in the opportunity loss table. So here is the assignment conclusion. Assignment problem deals with the problem of assigning job to machines or men to jobs which are to be performed by varying efficiency. So the perfect job is given to the perfect employee, and to assign a job, it can be used to solve cases of traveling salesman problem. It is basically minimizing model, but it can be used to solve cases of maximization by converting its cost table into opportunity cost loss table. So thank you for listening my PPT.